Morning, guys. This time we're gonna learn about a topic which is called concentration of solutions, and we have two main equations, molarity and molality. And today's topic is about molarity. This is the equation. It relates moles of solute divided by liters of solution. Solute is the substance that is about to be solved, okay? Like, for example, sugar in a coffee. For example, you add a spoon of sugar in a cup of coffee. So if I measure the coffee in liters, and I know that I have sugar, and I know the chemical formula, therefore I know how many moles are those grams that I'm using, I can get the molarity of that solution, coffee plus the sugar. Now in this case we're talking about a solution that is prepared by dissolving 25 milliliters of ethanol, which has a chemical formula that long, as you can see, CH3CH2OH, and a density of 0.789 grams per milliliters, in enough water to produce 250 milliliters of solution. So basically what it's going to happen is that you're going to dissolve the ethanol. As you can see, it's given in milliliters. Ethanol is the one that is going to be dissolved, so it's the solute. But it says that I need moles of solute. So how can I turn these milliliters into mole? Easily. Take a look. Here they are giving us density. If you remember, in density we use a formula that is mass divided by volume. I did yesterday an exercise about it. And as I have volume and I have density, I can easily get the mass. Knowing the mass, I can get the moles by relating the molar mass. Okay, so here's the deal. Okay, let's write the givens of the problems. We have, let's see, 25 milliliters of CH3CH2OH. I have a density of the same substance that is 0.789 gram per milliliter. Now take a look. I'm not going to convert yet. Okay, I'm not going to convert yet. Wait. And enough water to produce the volume of solution is in liter is 250 milliliters, but according to the formula I need it to be in liters, so I need to perform this calculation, and they're asking me to find molarity. So the idea of this problem is that we convert, first of all we define what is the solute and the solution. The solution is equal to the solute plus the solvent. Now the solute is the substance that is going to be dissolved. In this case is ethanol, and the solvent that is water. So the solute here is just the ethanol. What do I want to know about the solute? I want to know the number of moles. I don't have it. I have the milliliters and I have the density. So in the first step, what I'm going to do is calculate the mass of solute. I will calculate mass of solute Okay, it almost says volute, but imagine it's a perfect S. Now what I have to get it. Okay, I have 25 milliliters of the substance, and I know it has a density. So basically mass is going to be equal to the volume times density. The density is 0.789 gram per milliliter. So take a look here. As I have milliliters and milliliters, they're going to be cancelled, and I use the calculator So I have 25 times 0.789. I have a mass equals to 19.73 grams. Now I have grams. What's gonna happen? I will use the molar mass to get number of moles, because the thing that relates grams and moles is the molar mass. So molar mass of what? Of the solid. The solid is ethanol, and this is the chemical composition. So the molar mass, I will do the calculation here. I have CH3, CH2OH. So I have carbon, I have 2 carbons, 2 times 12. I have hydrogen, 1, 2, okay, I have 1, 2, 3, and 3 makes 6. I have 6 hydrogens, and the mass is 1. And I have 1 oxygen. Oxygen is 16, and I have just 1. Well, you understand the idea. Okay, so I have 24 plus 6 plus 16. 24 plus 6 plus 16 is going to give me 46 grams, the molar mass. So, now, the number of moles is calculated by using this conversion. 19.73 grams of ethanol. I will write the word better. And now here I'm going to use the molar mass. So I know there are 46 grams of ethanol in 1 mole of the same substance, ethanol, right here. Now I will cancel the same units that are in different positions, and I have 19.73 divided by 46. I have 0.43 rounded mole of ethanol. So this is my solid. So what I'm gonna do in the part 2 of my problem is to get the molarity. That is actually what I'm looking for. So I've just applied the equation molarity equals 2 moles of solid divided by liters of solution. But I didn't convert milliliters to liters, so just divide by 1,000. 250 milliliters by 1,000 divided by 1,000 is going to give you 0.25 liters. So this is going to be 0.43 mole of ethanol divided by 0.25 liters of the solution. And the solution, remember, is ethanol plus water. So this is equal, molarity is equal to 0.43 divided by 0.25. Okay, so my molarity here is 1.72, and the letter that we used, or the unit that we used to express molarity, is uppercase M. So the molarity of this solution is uppercase M, 1.72 molar. This is my answer to this problem. Now for the second problem, it's always about molarity. They are giving me, well, they're asking me what mass of, okay, K2CrO4 is potassium chromate. What mass of potassium chromate is needed to prepare exactly 0.25 liters of a 0.25 molar concentrated potassium chromate solution in water? Okay, so first of all we need to define what the solid and the solution is. The solution, we're going to represent solution like this, sol and an N. The solution is made of the solid plus the solvent. The solid is the substance that is going to be dissolved. In this case, we are talking about potassium chromate. So it's going to be potassium chromate plus the solvent. It says that it's going to be dissolved in water. So that is the solution. Therefore, the solute is potassium chromate, and the solvent is it's water. Okay, like this is like the general analysis of this solution that we are preparing. Now we write the givens. What do we have in the givens? They're asking us to find mass. So I want to know what the mass is. The mass of what? Of potassium chromate. Interesting. Because according to the formula, we are not relating mass in any of these, only moles and liter of solution. But let's see what happens. Now it's also given me the solution. The volume of the solution is 0.25 liters, and they are giving me the molarity of the solution too. I mean, how concentrated is the solution. So it says the molarity is 0.25 m molar. So as I want to know what is the mass of my potassium chromate, I know potassium chromate is my solute, so I will isolate for my solute first. So I say in the first part, I have molarity equals mole of solute divided by liters of solution. So I want to know the moles of solute, so it will be equal to, this was divided, goes to the other side to multiply, volume of solution times the molarity. The volume of solution is 0.25 liters, and the molarity is 0.25 m. So I just perform this in the calculator. So this gives me 0.0625 mole of solute. Okay, mole of potassium chromate. Okay, I have my number of moles, but I don't need moles, I need mass. So what I'm going to do, I'm going to convert from moles, from number of moles, to mass. How? What relates moles and mass? If I have mole and I want mass, I need to relate what we know as the molar mass. Molar mass of what? Of the substance that we're talking about, the solid. Okay, so we're gonna get the molar mass here of potassium chromate. We have 2 potassiums, we have 1 chromate, and we have 4 oxygens. And I'm going to write their molar masses that I have right here. Let's see. For potassium, the molar mass is 39.098. You know, this could vary according to the periodic table that you have. This is the one that I have, the one in Spanish. Chromium is 51.996, and oxygen, well, I'm gonna use 16. Okay, so get the molar mass. This is the molar mass that I got, 194.19 gram per mole. So I will do the conversion right now. So from mole to mass, I have my given, that is 0.0625 mole of potassium chromate times in 1 mole of my molar mass, which is in 1 mole of potassium chromate, I have this amount of grams, 194.19 grams of the same substance. So this gives me a total in grams of, let's see, 0.0625 times 194.19, 0.14 grams of solid, which is potassium chromate. So this is how we basically solve this problem. This is the answer of the problem, and this is it, guys. Just remember to analyze carefully. Even if we basically don't use this part, it's good to do it. It's good to analyze what is given. So thank you for watching. I hope you understood the topic today. If you have any doubt, you can send me a message. Thank you so much for doing your best effort. Goodbye.